There is a stone room in southern Egypt that most people will never visit. It sits beneath a temple that has stood for more than 2,000 years, accessible only through passages so narrow you have to turn sideways to enter. And it stays cool even in the burning heart of an Egyptian summer, because the walls are thick and the stone does not forget the cold of deeper things. Inside that room, carved into the wall with a precision that still makes engineers pause, there is an image that the ancient world had no business creating. The Temple of Dendera rises from the desert like a quiet argument against time. Its columns are immense, its halls are long. The carvings that cover its walls stretch from floor to ceiling, without interruption, a continuous conversation in stone that has been waiting centuries for the right person to overhear it. Millions of eyes have moved across these surfaces. Archaeologists, travelers, priests of other faiths, soldiers of 3 different empires. All of them have walked through this building and seen its surfaces and understood it as a temple, as a religious monument, as an artifact of dead belief. Most of them looked at the right wall and saw the wrong thing. The image is carved in one of the building's sealed underground crypts. It shows a shape that is difficult to describe without reaching for a word the ancient Egyptians could not have possessed. The shape is elongated, widest at the center, tapering symmetrically at both ends. Inside it, something coils a form suspended within the oval body, touching its inner walls at specific points, following a precise, curved path from one end of the enclosure to the other. The whole object rests on a base shaped like the spread petals of an opening lotus, and between the base and the body there rises a pillar whose structural proportions are, by any objective measurement, unusual for a decorative column in a religious context. The investigation you are about to follow is not an argument that the mainstream understanding of Egyptian history is entirely wrong. It is an argument that the mainstream understanding is incomplete specifically, that it is incomplete in a domain where incompleteness has significant consequences for how we understand what human beings have been capable of across the long arc of time. The evidence presented here has been gathered from multiple independent fields: electrical engineering, geophysics, materials science, comparative mythology, architectural analysis, and archaeological chemistry. No single field has the complete picture. No single field has been designed to ask the complete question. What follows is an attempt to bring those fields into conversation around a question that all of them, individually, have found reasons to avoid. 3,000 years before electricity was officially discovered, before the first patent for a light-emitting device was filed, before any scientist in any European laboratory had mapped the behavior of electrical discharge through a sealed glass vessel, someone in this underground room picked up a chisel and made this. They did it carefully. They did it accurately. They did it in the most protected and most precisely constructed chamber in one of the most sophisticated buildings the ancient world produced. And when they were done, they sealed the room behind them and left no explanation that we have yet been able to read. That image has been waiting in the dark for more than 2,000 years. In the time since the last person who fully understood it died, entire civilizations rose and collapsed. Languages were born and extinguished. The knowledge of how to read the very script that surrounds this image was lost for 1,500 years before European scholars painfully recovered it. And through all of that time, through every disruption and every erasure, this carving survived intact. It survived perhaps because it was hidden. And it may have been hidden because whoever placed it there knew exactly what it showed, and knew that the world outside those sealed stone walls was not yet ready to understand it. The Egyptians left us an answer. We just forgot how to read it. The official explanation for the Dendera carvings is not unreasonable. It is, in fact, internally consistent, and it would be dishonest to present the scholarly position as though it were ignorant or careless. Academic Egyptologists, the people whose professional lives are spent reading the language in which these reliefs are inscribed, have a clear interpretation that the scholarly community has largely accepted. But there is a difference between an explanation that is reasonable and an explanation that is complete, and the official story of the Dendera carvings has a number of quiet places where the reasoning becomes very thin. The mainstream interpretation holds that the images in question are religious tableaux. The elongated oval shape is not a glass vessel, it is a lotus pod, a representation of the primordial flower from which the sun god Ra emerged at the creation of the world. The coiling form inside it is not a filament or a suspended element, it is a serpent, representing Ra himself in his travelling aspect, or the chaos serpent Apophis, depending on which ancient text you consult. The pillar connecting the base to the body is a D-jade pillar, a standard symbol of stability, and the spine of the god Osiris, found across Egyptian religious art. And the human figures arranged around the object are priests, engaged in a ritual of cosmic significance. None of these identifications is invented. The lotus flower is a foundational image in Egyptian creation theology. The serpent is one of the oldest symbols in the Egyptian religious vocabulary. The D-jade pillar appears in hundreds of contexts across dozens of sites. Taken individually, each element of the official interpretation is supportable. The problem begins when you ask why these particular elements, combined in this particular configuration, produce an image whose structural geometry maps with unusual precision onto a specific piece of 19th century laboratory equipment called a Crookes tube. A Crookes tube is a sealed glass vessel, elongated and oval, containing a filament suspended along its internal axis, used by the Victorian physicist William Crookes to study cathode rays. When powered, the filament inside a Crookes tube glows. The tube becomes luminous. It produces, in a darkened room, the appearance of a snake made of light. If you show a photograph of the Dendera relief to an electrical engineer covering the surrounding context, so they cannot see the hieroglyphs or the temple setting, and you ask them what it depicts, they do not describe a lotus pod and a creation myth. They describe an insulated glass discharge tube mounted on a terminal block. They notice that the position of the internal form corresponds exactly to where a cathode ray filament would sit. They notice that the proportions of the base correspond to those of an electrical insulator. They notice that the column connecting the base to the body matches the function of a high-voltage standoff, a device specifically designed to prevent current from grounding through its support structure. The official explanation does not engage with this. It cannot, because its interpretive framework has no category for it. The lotus pod interpretation describes the mythology behind the image without interrogating the engineering precision of its execution. And that gap between what the image symbolizes and what it structurally resembles is not a small gap. It is the gap into which an entire lost chapter of human technical knowledge may have fallen. The mainstream scholars are not wrong in their symbolic reading. They may simply be describing the cover story rather than the content. Ancient civilizations regularly embedded practical knowledge inside religious narrative. It was the safest way to transmit information across generations, in a world where institutions could collapse and libraries could burn. What if the lotus flower was not a replacement for a technical drawing? What if it was the disguise one wore to survive? There is also a deeper strangeness to the official response that is worth naming. When scholars encounter images that suggest advanced technical knowledge in ancient contexts, the default interpretive response is not curiosity, it is categorization. The image is assigned to a known symbolic system, fitted with an existing mythological label, and filed away. This process is not dishonest. It reflects the genuine methodological priority of a discipline, whose primary tool is textual and cultural analysis. But it has a systematic blind spot. It is far better at identifying what an image resembles in the existing mythological vocabulary than at identifying what it resembles in technical reality. A Crookes tube was invented in 1875. Egyptian mythology was fully developed by 3000 BCE. In a purely disciplinary competition, mythology wins by default, not because it is the better explanation, but because it is the only explanation the available tools are equipped to produce. The question of whether the image might also describe a technical reality falls outside the frame, and questions outside the frame are not answered. They are not even asked. Before going deeper into what the image depicts, it is worth pausing on where the image was placed. Not every wall in ancient Egypt was created equal. Not every surface was appropriate for every kind of content. The Egyptians were among the most deliberately spatial cultures in recorded history. The placement of an image, its height, its orientation, its relationship to surrounding imagery, all carried meaning. The location of the Dendera electrical reliefs is not incidental. It is one of the most striking things about them. These images were not placed in the main hall. They were not displayed in the forecourt where ordinary worshippers gathered. They were not carved on the outer walls, where travelers approaching the temple would see them. They are in the crypts, a network of underground chambers running beneath the outer walls of the main structure, sealed behind hidden entrances that appear to be solid stone, until you know precisely where to press. In total, the Temple of Dendera has 14 such crypts, and they constitute one of the most extensive and carefully engineered underground spaces in all of Egyptian religious architecture. These were not storage rooms. The stone crypts of Dendera are finished to a higher standard than many of the more publicly visible areas above them. Their walls are plastered. Their surfaces are carved with the same extraordinary care as the temple's most sacred inner sanctum. And the texts inscribed in them, the hieroglyphic captions that run alongside the images, and between them and above them, in dense, unbroken columns, are not the simplified versions of temple text used for broad public communication. They are technical in register. They assume knowledge on the part of the reader. Multiple ancient sources refer to these chambers by a specific term that translates, roughly, as the place of the hidden things. A separate set of inscriptions found within the crypts themselves describes their function as rooms where objects could be charged or filled with what the texts call the force of the god, not decorated with, not blessed with, filled with. The language is operational. It describes a process with a beginning, a middle, and an end. And then there is the detail that becomes impossible to dismiss once you have noticed it. The inscription in one of the crypts does not describe the light inside the room as arriving through windows or oil lamps or any conventional means. It describes a light that persists, a light that does not require fire, a light that the texts associate specifically with the objects housed in these rooms, the metal objects, the instruments, the things the priests describe as having their own inner force. These crypts were not incidental. They were designed, from their orientation to their dimensions, to their material composition, with extraordinary specificity. Whatever was being protected and operated in these rooms was important enough to hide, complex enough to require specialist knowledge to manage, and significant enough to record in the most technically precise language the Egyptian scribal tradition possessed. The image on the wall is not graffiti, and it is not decoration. It is a diagram. And diagrams describe real things. There is one further observation about the crypts that belongs here, before this investigation moves forward. The Dendera temple is not the only Egyptian site with underground chambers displaying unusual technical reliefs. The temple at Edfu, approximately 60 miles to the south, contains a crypt system of comparable sophistication, with inscriptions that reference similar operational procedures for objects described in terms that align with the Dendera descriptions. The temple at Abydos, another 100 miles north, contains chambers that show similar themes of concealed technical operation. The pattern of hidden underground technical chambers in major Egyptian temples is not unique to Dendera. It is a feature of the most significant Egyptian temple sites built during the period of maximum priestly technical sophistication. Dendera is the most explicit surviving example because its crypts are the most intact, but it is not an isolated anomaly. It is the clearest surviving expression of a widespread institutional practice. That context matters enormously for the investigation ahead. The history most people learn about ancient Egypt begins with the unification of the two kingdoms, Upper and Lower Egypt, under a king named Narmer, around 3100 BCE. That is the official starting point, the clean, bold date in the textbook, the moment when a civilization supposedly emerged from the desert and began building things of lasting significance. It is a tidy origin story. It is also, in specific and documented ways, demonstrably incomplete. The Egyptians themselves did not believe their civilization began with Narmer. The pharaohs of the dynastic period, the kings who built the temples, commissioned the monuments, and left the records that archaeologists have spent 2 centuries decoding, consistently describe themselves not as founders, but as inheritors. Their texts speak of a time before the historical period, a golden era they called Zep Tepi, the first time. In this earlier age, they wrote, the gods themselves walked the earth and governed directly. The world was ordered according to principles of perfect knowledge. Every science was known. Every natural force was understood and made useful. And then, somehow, That age ended, and the pharaohs received what remained of its wisdom as a legacy they had not earned, not as an invention they had achieved. Mainstream Egyptology classifies this as mythology and moves on. That classification has the virtue of simplicity and the limitation of incuriosity. Because when you stop treating Zep Tepi as a story and start treating it as a claim made by sophisticated, literate, technically capable people who had no obvious reason to invent it, the archaeological landscape begins to look different. The Sphinx at Giza carries on its body a form of erosion that geologists specifically associate with heavy rainfall over extended periods. The last time the Giza Plateau received that volume of rainfall was somewhere between 7 and 10,000 years ago, not 3,000. The astronomical alignments of the Giza Pyramid complex correspond with precision to the position of specific star formations as they appeared in approximately 10,500 BCE. These are not fringe observations. They have been published in peer-reviewed journals and debated seriously by professionals with no attachment to alternative history. None of this proves that the Dendera electrical system is real, but it establishes something important as a foundation. The history of ancient Egyptian civilization is considerably more complex and probably considerably longer than the standard timeline acknowledges. If an earlier civilization existed sophisticated enough to produce the astronomical and engineering knowledge that the dynastic Egyptians inherited rather than invented, then the presence of advanced technical knowledge encoded in the walls of Dendera is not an isolated anomaly requiring an extraordinary explanation. It is consistent with a pattern the evidence already suggests. The pharaohs said they inherited something vast from those who came before. Perhaps it is finally time to take them at their word and follow that inheritance to see where it leads. The concept of Zep Tepi also appears in the architectural texts of the temples themselves, not as background mythology but as an explicit design justification. Temple construction inscriptions at multiple sites, including Dendera, state that the building was constructed according to plans dating from Zep Tepi, preserved on a document written in the time of the ancestors. The phrase used for this foundational document translates literally as the plans that fell from heaven in the time before time. Scholars have interpreted this as religious hyperbole, a way of claiming divine sanction for architectural decisions. But the possibility that the phrases describe something more literal, actual, transmitted records from a civilization that preceded the historical Egyptian period deserves consideration that it has rarely received. When a builder claims to be following ancient plans that originated in a prior golden age, the default academic response is to treat it as rhetorical flourish. The alternative is to ask, what if the plans were real? What if the builder was telling the truth about where they came from? Before asking whether the ancient Egyptians understood electricity, it is worth establishing what they demonstrably understood. The list is longer and more technically impressive than popular history typically presents, and this matters not as proof that they must have had electrical knowledge, but as a calibration of what the word impossible should mean when applied to this civilization. The Edwin Smith Papyrus is a medical document dating to approximately 1600 BCE, though most scholars believe it copies from a considerably older original. It describes 48 surgical cases in systematic, clinical language organized case studies, numbered and formatted in the way modern medical literature organizes differential diagnoses and treatment protocols. Several of those cases concern injuries to the brain and spinal cord, and the descriptions are accurate. The papyrus identifies that motor control in the limbs is governed by structures in the neck. It distinguishes between types of neurological damage based on observable outcomes. It recommends different responses, including, for some cases, honest acknowledgement that no treatment would be effective based on diagnostic criteria that remain clinically defensible today. Egyptian doctors understood the nervous system 4,000 years ago. Egyptian blue, the synthetic pigment that coated the walls of countless ancient Egyptian structures, requires a synthesis temperature between 850 and 1000 degrees Celsius, held with unusual stability over a long firing period. The particle size of Egyptian blue affects its optical properties, and ancient specimens analyzed under electron microscopy show a consistency in particle size that implies precisely controlled production. This is not pottery kiln chemistry. It is precision material synthesis, requiring specific knowledge of mineral reactions and thermal management. The Egyptians produced it reliably for more than 3,000 years. The acoustic properties of the hypostyle hall at Karnak, a chamber of 134 massive columns arranged like a forest of stone, are not accidental. Acoustic modeling has shown that the column arrangement creates specific resonance patterns at frequencies used in ritual chanting, amplifying sound in ways that produced experiences of unusual intensity for participants. The engineers who designed Karnak understood the relationship between physical geometry and sonic behavior. If the Egyptians understood surgical neuroanatomy, precision materials, chemistry, and architectural acoustics, all of which the evidence directly confirms, the question is not whether they were capable of understanding electrical principles. It is whether they encountered those principles and recognized them. That question, as the following chapters will show, has a specific and surprising answer. The connection between verified Egyptian scientific achievement and the electricity hypothesis is not merely rhetorical, it has a specific physical dimension that is worth making explicit. Each of the verified domains of Egyptian scientific competence required not just observational knowledge, but systematic experimentation over extended periods. You do not arrive at the precise synthesis temperature for Egyptian blue by accident. You arrive at it through a long process of controlled testing, record-keeping, and incremental refinement. You do not map the resonant frequencies of a stone hall by intuition. You measure them, systematically, across many iterations. The Egyptians possessed, demonstrably, both the institutional infrastructure for extended systematic experimentation and the recording and transmission systems necessary to preserve the results of that experimentation across generations. A civilization with those capabilities, located on top of a geological formation that produces measurable electrical current, would have had both the tools and the inclination to notice, investigate, and ultimately exploit the phenomenon. When we use the word temple in connection with ancient Egypt, a specific set of images arises automatically in most minds. Columns decorated with painted figures, incense, smoke, priests in white linen, the chanting of prayers, the movement of ritual objects in service of a god. These images are not wrong, but they are incomplete in a way that matters enormously for understanding what the Temple of Dendera actually was and what it actually did. The ancient Egyptian temple was not primarily a place of congregational worship in the sense that modern religious buildings are. Ordinary people did not enter the inner sanctums. They gathered in courtyards and outer halls, while the inner machinery of the institution operated behind closed doors, managed by specialists who spent years in training before they were permitted to touch the instruments or read the texts. The temple was a functioning institution with a budget, a staff hierarchy, a curriculum, and a research program. It was, in many practical respects, closer to a university research facility than to a house of prayer. This becomes clearer when you examine the titles that Egyptian priests held, not the honorary titles associated with their rank in the religious hierarchy, but the functional descriptors attached to their specific roles. The Temple of Dendera records priests with titles that translate as Keeper of the Secrets of Heaven, and One who knows what is hidden in the chambers, and Master of the Science of the Stars. These are not poetic epithets. They are job descriptions for people who held specific technical responsibilities, requiring specific technical knowledge. Knowledge carefully restricted to those who had proven themselves capable of receiving it, without misunderstanding or misusing it. The institution attached to major Egyptian temples was called the Per-Ankh, the House of Life. This was simultaneously a library, a school, a scriptorium, and a workshop. The Per-Ankh at Dendera was considered among the most significant in the entire country. Its holdings were restricted by priestly rank, its instruction conducted in graduated stages, and its curriculum encompassed astronomy, medicine, mathematics, ritual technology, and what the Egyptians called heka, a word typically translated as magic, but whose practical meaning, as this investigation will examine in detail, was considerably more specific than that translation implies. When modern analysts examined the composition of the wall plaster in the Dendera crypts, they found something unusual. The plaster contains significant quantities of magnetite, a naturally magnetic iron oxide, with no obvious aesthetic or structural purpose in a wall covering. Magnetite does not make walls more attractive. It does not improve their durability. What it does, measurably and definitively, is increase their electrical conductivity above that of ordinary gypsum plaster. Nobody adds an expensive mineral compound to a building material without a reason. Whatever that reason was at Dendera, it was not decoration. The temple was not just a building. It was a machine designed to do something specific, and the full scope of what it was designed to do is only beginning to become clear. If you were to follow a scholar through the entrance that leads to the southern crypt of the Temple of Dendera, you would begin by passing through a doorway so narrow that turning sideways is not optional. The passage beyond it is not a corridor in any comfortable sense. It is a slot, cut through stone, barely wide enough for a person moving carefully, and it descends at a shallow angle before leveling into a space that takes the eyes a moment to adjust to even with modern lighting. The ceiling is low. Standing fully upright is possible only at the center of the room, and the walls close in as you approach the corners. Two people standing side by side fill the available width nearly completely. This is a space designed for intimate interaction with whatever it contains, not for gathering or procession or any kind of communal performance. And then there are the walls. From the floor, rising to the ceiling, covering every surface that is not a doorway or a passage opening, the reliefs begin. They do not stop. There is no uncarved space, no neutral surface where the stone has been left to breathe. Every centimeter of the crypt's interior walls carries imagery and text, and the imagery is finer than almost anything visible in the public sections of the temple above. The figures are precisely proportioned. The objects they hold and surround are geometrically specific in ways that do not always correspond to standard Egyptian decorative conventions. The hieroglyphic text runs in tight columns between the figures, dense and uninterrupted, as though whoever composed it had a great deal to say and limited space in which to say it. The southern crypt houses the most discussed of the Dendera underground reliefs. On the east wall, 3 large panels depict objects that are unlike anything else in Egyptian religious art. The first panel shows the central form most clearly, an elongated, sealed oval body, widest at its middle third and tapering symmetrically toward 2 ends. Inside the body, a serpentine form stretches along the central axis, its head near one tapered end, and its body following the gentle curve of the vessel's longest dimension. The oval rests on a lotus-form base, and from that base rises the D-jade pillar, the column of stability which connects the base to the body of the oval, at a structural point that becomes highly significant when the image is examined from an engineering perspective. Around the central object, human figures stand in fixed positions. Their arms are extended. Their postures are formal in the manner of Egyptian ritual representation, but the angles they maintain are specific, and the distances between the figures and the central object have a consistency that does not appear in purely symbolic compositions. The whole scene has the character of a procedure rather than a ceremony. Something is being done, step by step, by people who know the sequence. The relief was carved in a sealed underground chamber, hidden from public access, in the most precisely engineered building of its era. This was not an afterthought. This was a message. And the question that has occupied careful observers for decades is, a message about what, exactly? The density of the carving in the southern crypt is worth dwelling on for a moment, because it communicates something important about the priority that the people who made it assigned to its content. Egyptian craftsmen were extraordinarily skilled, but their time was also extraordinarily valuable. The resources required to produce the level of carving present in the Dendera crypts the skilled labor. The materials, the sustained organizational support were not trivial. Major Egyptian relief programs were commissioned and funded by institutions with specific purposes, and the degree of investment in a given surface's imagery was a direct measure of the importance assigned to its content. The Dendera crypt reliefs received an investment of precision and detail comparable to the most sacred public surfaces of the main temple above, and in some respects exceeding it, despite being located in rooms that the vast majority of people who entered the building above them would never know existed. Whatever was being communicated in these rooms was worth every resource that was spent communicating it. In 1875, a physicist named William Crookes sealed a glass tube, evacuated most of its air, inserted 2 metal electrodes at opposite ends, and passed electrical current through it. What happened inside the tube changed the course of scientific history. A glowing discharge appeared along the tube's internal axis, moving from one electrode to the other, behaving in ways that defied the existing understanding of electricity. Crookes spent years studying this phenomenon, the stream of charged particles that later science would identify as electrons. His device became the direct precursor to cathode ray tubes, X-ray technology, fluorescent lighting, and ultimately the vacuum tubes that powered the first computers. The Crookes tube is, in a direct technical lineage, the ancestor of every screen and every piece of electronic equipment that defines modern life. It is also, in 7 specific and measurable ways, structurally identical to the central object depicted in the Dendera crypt relief. The first correspondence is the outer form. A Crookes tube is elongated and oval, bulging at its widest point to approximately 1/3 of its length, and tapering symmetrically at both ends toward its electrode connections. The Dendera relief shows an object with precisely this geometry, the same ratio of maximum width to total length, the same bilateral taper, the same distribution of volume along the central axis. When the proportions of both objects are plotted on the same scale, the geometric match is exact. The second correspondence is the internal element. In a functioning Crookes tube, the cathode ray discharge appears as a luminous streak along the tube's axis, following its curvature from cathode to anode. In the Dendera relief, the serpent inside the oval follows exactly this path along the central axis, from one tapered end toward the other, curving slightly as the tube's cross-section demands. A serpent inside a container normally coils or rests on the container's floor. This one does not. It extends along a linear path with a slight arc that exactly matches the behavior of a sustained electrical discharge. The third correspondence is the base terminal. In a discharge tube, the electrode at the cathode end connects to the tube through a precise fitting that maintains electrical contact while supporting the structural weight of the device. The lotus-shaped base in the relief connects to the oval body at the same geometric point, at the same angle, through a joining form whose proportions match a terminal connection rather than a purely decorative base. The fourth correspondence is the D-jade pillar. Between the lotus base and the oval body, the pillar in the relief performs a specific function that is not immediately obvious from a religious symbolism perspective. It separates the base terminal from the main body of the object by a fixed, non-conducting distance. This is precisely what a high-voltage standoff insulator does. It prevents electrical current from taking a shorter path to ground through the support structure. You do not mount a discharge device directly on a grounded surface. You mount it on an insulator. The D-jade pillar, structurally, is an insulator. The fifth correspondence involves the human figures. The ritual attendants in the relief stand at fixed distances from the central object. Their arm positions are extended but not touching the device. This configuration proximity, without contact, is the standard safe-handling posture for persons working near a high-voltage apparatus. The sixth correspondence is the secondary lotus at the far end of the device. In a discharge tube, the anode, the positive electrode, where the cathode ray terminates, is located at the end, opposite the cathode. In the Dendera relief, the second lotus form appears at exactly this position. It serves no clear mythological function that could not be served equally by the first lotus alone. The seventh, and perhaps most striking correspondence, appears in a second version of the Dendera relief on the adjacent panel. In this version, the internal serpent divides at its midpoint into 2 separate forms, each traveling to a different region of the interior. No Egyptian mythological tradition describes a creation serpent that splits in 2 inside a lotus pod. But a split-filament Crookes tube, a specific design variant used to produce discharge at 2 different points within the same vessel, has exactly this internal configuration. 7 correspondences, all in a single image, all consistent with a functioning electrical discharge device. At some point, coincidence requires its own explanation. The famous lamp image is the one that appears in articles, documentaries, and online discussions about ancient Egyptian electricity. It is the image that launched 1,000 arguments. And because it is the most visually striking element of the crypt reliefs, it has attracted the large majority of attention, so much so that what surrounds it has gone almost entirely undiscussed. This is a significant oversight, because when you pull back from the famous panel and look at the complete visual program of the southern crypt. What you see is not one anomalous image embedded in a conventional religious scheme. What you see is a system. Directly adjacent to the primary lamp relief, on the same wall and clearly part of the same compositional scheme, there is an image of what conventional Egyptology describes as a snake rope, a coiled form, elongated and flexible, with regular spacing along its length. The snake rope interpretation is not unreasonable as far as it goes. But the geometric regularity of the coiling in this image, the consistency of its loop diameter, and the manner in which it connects at both ends to other structural forms in the composition correspond precisely to the visual representation of a braided or wrapped electrical conductor. Not a rope with a snake pattern, the specific visual idiom that an artist depicting a conducting cable would produce if they were working from observation of a real object. Cables look like this. Ropes do not have uniform loop diameter throughout their length. Above, and to one side of the lamp panel, a second relief shows a figure standing at a tall, vertically oriented column that contains interior divisions at regular intervals. The conventional interpretation describes this as a figure making an offering at a ritual column. But the internal structure of this column, the divisions, their regularity, the way the figure appears to be interacting with the column's interior components, rather than simply presenting something to its outer surface, corresponds to the visual logic of a bank of electrolytic cells. An electrolytic cell is a container filled with a conductive solution, with electrodes inserted at regular intervals, used to store and release electrical charge. The Baghdad Battery, which this investigation will examine shortly, is a single such cell. A bank of cells connected in sequence is a battery pack. The figure in this relief appears to be operating one. A third image in the crypt complex shows two figures on opposite sides of an oval form, each extending their arms toward its surface, each appearing to connect something to the object from their respective positions. The precise mirror symmetry of this composition, two figures, one on each side, making identical connecting gestures at opposite poles of the central object, has no clear parallel in Egyptian ritual imagery, where the arrangement of figures around sacred objects follows well-established asymmetric conventions rooted in theological hierarchy. It does have a clear parallel in the process of connecting a discharge tube to dual power terminals, one at each end, one positive, one negative, both necessary for operation. Now consider the texts that accompany these images. The hieroglyphic captions running through the southern crypt have been translated by Egyptologists primarily interested in religious content, and their translations reflect that priority. But even through a theological interpretive filter, certain phrasings are difficult to spiritualize away entirely. The serpent releases the essence of Ra into the lotus body. The pillar of stability carries the force without allowing it to scatter. The light that comes from the hidden place does not come from burning. The light that does not come from burning. This is not a poetic flourish. It is a technical distinction. An oil lamp burns. A torch burns. A fire burns. Whatever is being described in the Dendera crypt texts produces light, but it does not burn. The scribe who wrote this knew the difference and thought it worth recording specifically. The distinction between a combustion light source and a non-combustion one is exactly the distinction between a flame and an electrical discharge. Both produce light, only one burns. Taken together, the lamp, the cable, the cell bank, the dual terminal connection, and the operational texts, the southern crypt of the Temple of Dendera, does not present one anomalous image surrounded by standard religious content. It presents a coherent visual and textual description of a multi-component electrical apparatus, where each element has its place in the system. Each is labeled with text describing a function, and the complete composition reads, for anyone with the right background, as a technical schematic rather than a mythological tableau. The individual images can perhaps be explained away one at a time. The system they form cannot. The system interpretation also resolves an otherwise puzzling aspect of the crypt's visual organization. In standard Egyptian temple decoration, the arrangement of images follows a hierarchical logic derived from theological relationships. More important figures are larger, positioned higher, or located in more central areas. The compositional scheme of the southern crypt deviates from this logic in ways that make no sense, if the images are purely religious symbols, but make complete sense if they are functional components of a depicted apparatus. The cable image is positioned at the logical input end of the system. The cell bank image is positioned between the cable and the primary lamp relief. The lamp relief is positioned at the logical output end. The dual terminal connection image is positioned to show how power is delivered to the device from both ends simultaneously. This is not an iconographic hierarchy. It is a sequence diagram showing, in the spatial logic of the room's east wall, the flow of energy from source through storage, through delivery, through discharge. Read the room left to right or bottom to top, and you are reading an electrical schematic. In 1936, in a museum in Baghdad, a German archaeologist named Wilhelm König opened a storage case and found something that had no name in any archaeological catalogue because nothing like it had been found before. It was a clay jar, about 14 centimeters tall, sealed at the top with a layer of asphalt. Inside the jar, held in place by that asphalt seal, was a copper cylinder. Inside the cylinder, held in place and insulated from direct contact with the copper by a further layer of asphalt, was an iron rod. The components fit together with a precision that was not accidental. König had handled enough ancient artifacts to recognize the quality of the craftsmanship. He also had enough physics education to recognize the configuration. What he was holding was an electrochemical cell, a battery. The principle of the electrochemical battery had been published by Alessandro Volta in 1800. The device in König's hands predated that discovery. By more than 2,000 years it was dated to the Parthian period, approximately 250 BCE. König published his interpretation in 1940, carefully, with measurements and a chemical analysis of the residual material found inside the copper cylinder, which was consistent with an acidic solution having once been present. He proposed that whoever built this device understood, at a practical level, that a metal cylinder containing an acidic liquid, with a dissimilar metal rod inserted through its axis, would produce a measurable electrical potential. The academic response was notable primarily for what it did not contain, a convincing alternative explanation. Skeptics noted that there was no accompanying electrical apparatus, no circuit, no connected device. They proposed the jar might have been used for storage of scrolls or as a simple container, but the structural sophistication of the device, the specific choice of dissimilar metals, the insulating asphalt separating them, the seal design is completely unexplained by the scroll storage hypothesis. A storage jar does not need an insulated iron rod precisely centered at its core. In the decades following König's publication, several researchers built working replicas of the Baghdad Battery and tested them. Filled with grape juice, a naturally acidic solution available throughout ancient Mesopotamia, the replicas produced between 1.5 and 2 volts of electrical current. Not enormous. Not enough to power any substantial device, but enough for a specific purpose that the same ancient cultures that produced the Baghdad Battery also demonstrated a mysterious mastery of electroplating. Electroplating is the process of depositing a thin, uniform layer of one metal onto the surface of another by passing electrical current through a conductive solution. It requires a consistent voltage source. It requires knowledge of which metal and solution combinations produce the desired deposit. And it produces results, thin coatings of gold or silver on base metal objects, uniform in thickness, that are extremely difficult to replicate by any other method available in the ancient world. Several museum collections contain ancient Near Eastern artifacts, whose gold coatings have been analyzed and found to have a uniformity of thickness that strongly suggests electroplating. Even though electroplating was not supposed to exist until the 19th century, the Baghdad Battery provides the mechanism for what those coatings required. The silence that met König's proposal was never really broken by a better answer. The academic world did not prove him wrong. It absorbed his observation, filed it in the unsettling category, and moved forward. The battery sat in its museum case, generating no discourse, waiting for a wider investigation to catch up with it. The Baghdad Battery demonstrates that ancient civilizations understood electrochemical power generation. But the kind of electrical effect depicted in the Dendera crypt reliefs a glowing discharge inside a sealed glass vessel, requires considerably more voltage than any ceramic battery can produce. Electrochemical cells are useful for gentle, sustained current. They are not suited to creating the high potential discharge that fills a sealed tube with visible light. If the Dendera system was real and functional, it needed something considerably more powerful than vinegar in a clay pot. The extraordinary possibility is that whatever the Dendera priests were drawing on was not manufactured at all. It was already there, running through the ground beneath their feet. The Earth is not electrically inert. The planet's atmosphere maintains a substantial electrical potential gradient relative to its surface, roughly 100 volts of potential difference for every meter of altitude, produced by the continuous exchange of charge between the ionosphere and the ground through global weather systems and solar activity. This atmospheric electrical field is always present, everywhere on Earth, at every moment of the day and night. We do not notice it because we are embedded within it, and our bodies are in equilibrium with it. But any structure that creates a differential between 2 points at different heights within this field will experience a measurable voltage across its vertical extent. Separately, certain geological formations generate their own electrical currents through a process called piezoelectricity. When crystalline materials, quartz is the most practically significant example, are subjected to mechanical stress, they generate an electrical charge. This charge is not static. It flows through any conductive path available as electrical current. The geological formations of the Nile Valley contain extensive deposits of limestone and sandstone with high quartz content, exactly the kind of formation that produces piezoelectric current under mechanical stress. And the region around Dendera is subject to continuous mechanical stress. The weight of the terrain above it, seismic activity along several fault lines that thread through Upper Egypt, and the seasonal expansion and contraction caused by the annual flooding of the Nile, which dramatically alters the distribution of weight across the entire valley floor. When the Nile floods, the geological formations beneath Dendera flex slightly under the redistributed weight of water-saturated soil. Piezoelectric materials under changing stress generate electrical current. This current flows through the conducting pathways in the rock, what earth scientists call telluric currents, and can be quite substantial in regions with high piezoelectric mineral content and frequent stress variation. Modern geophysical surveys of the Nile Valley have measured telluric current densities significantly above the global average, particularly during and immediately following the annual flood peak. The Egyptians did not need to invent a generator. They built their most technically sophisticated structures on top of a natural one, in a region where the ground itself produces measurable electrical potential on a seasonal schedule they could predict with precision. There is one additional dimension of the geological power source argument that deserves explicit treatment. The question of whether ancient peoples could have observed the electrical properties of piezoelectric materials without a formal understanding of the underlying physics. The answer is clearly yes. Quartz crystals in their natural form produce visible light when struck a phenomenon called triboluminescence, and produce measurable electrical sparks when subjected to mechanical stress. This is not subtle or hidden. It is directly observable with unaided senses, and it has been observed by people working with quartz across many cultures and many centuries. A civilization that worked extensively with quartz-bearing stone, as the Egyptians did, would have had abundant direct experience of the material's electrical properties, long before any formal physical theory existed to explain what they were observing. The step from observing that certain stones produce sparks under pressure to designing a building to maximize the collection of that pressure-produced current is a large one. But it is a step within the domain of systematic, empirical observation and intelligent structural reasoning, not a step that requires theoretical physics. The Egyptians were among history's most sophisticated empirical observers. The evidence of their buildings speaks to what they observed. An argument built on a single anomaly is fragile. Any one piece of evidence can be the product of coincidence, misinterpretation, or a unique set of local circumstances. But when multiple independent civilizations, separated by thousands of miles and operating within entirely different cultural and linguistic traditions, produce descriptions of the same phenomenon, in strikingly similar terms, the fragility of the single-source argument dissolves. What remains is a pattern, and patterns require explanation, Ancient Indian literature contains a text known as the Agastya Samhita, part of the broader body of Vedic scientific literature attributed to the sage Agastya. A particular passage within this text, translated from Sanskrit by the 19th century scholar Dayanand Saraswati, describes the construction of what can only be read as an electrochemical cell. The instructions specify a well-cleaned copper plate placed in an earthenware vessel, covered first with copper sulfate, then with moist sawdust, then topped with a zinc plate that has been amalgamated with mercury. The combination, the text states, produces energy known as mitra varuna. A modern chemist presented with this composition would confirm that it produces a galvanic cell, a working battery. The Vedic text does not use that term, but the operational result is identical. Mitra and Varuna are solar and lunar deities in the Vedic tradition. Their names in this context suggest polarity, something like positive and negative. The energy produced by their union in this device is described, in adjacent passages, as something that can illuminate a darkened space when directed through an appropriate vessel. The vessel described is elongated, sealed, and filled with specific gaseous compounds. By description, it is a discharge tube. Ancient Chinese technical literature contains a reference, in the Tang dynasty text Tong Dian, compiled around 800 CE, to metal tubes in the possession of certain learned academies that could, in a darkened room, project what the text calls a snake of light from one end to the other, illuminating the interior without flame. The Tong Dian is a governmental encyclopedia, not a work of mythology, and its descriptions of technology are elsewhere reliable and verifiable. The snake of light in a sealed tube is a description of cathode ray discharge, specific enough that treating it as figurative language requires deliberate effort. And from the Maya of Central America, the structures at Palenque contain a network of interior stone conduits, not drainage channels, as they are typically described, because their internal diameter, their positioning along structural walls, and their terminal points inside central chambers are inconsistent with drainage function. They originate at the highest points of the building, where lightning strikes occur most frequently. They follow the interior walls in straight vertical runs. They terminate at floor level in rooms near the building's center. The distribution path they trace follows the same logic as a lightning collection and distribution system. 4 ancient civilizations, 3 continents, approximately 3,000 years of documented history. Each description is different in its cultural vocabulary. Each is consistent in its technical content. The explanation that dismisses all 4 as independent religious coincidences is, at some point, harder to defend than the explanation that takes the pattern seriously. Architecture is never neutral. Every material choice a builder makes reflects either a constraint or a purpose, and when the builder is skilled enough to choose freely within a wide range of available options, their choices become the most direct available expression of their intentions. The architects of the Temple of Dendera were among the most capable builders in the ancient world. They had access to multiple quarry sources, extensive experience with diverse stone types, and the organizational capacity to transport and work materials across hundreds of miles of desert. When they made specific, unusual material choices for this specific building, those choices were not accidental. The primary stone used in the temple's construction is sandstone from a quarry at Gebel el-Silsila, a site located roughly 200 kilometers upstream from Dendera on the Nile. This quarry was not the nearest available stone source. Other quarries closer to Dendera could have provided adequate building material and would have significantly reduced the transportation cost and logistical complexity of the TEX project. Gebel el-Silsila sandstone was chosen for a reason. The reason, when the stone is analyzed chemically, becomes apparent. This particular sandstone contains an unusually high concentration of quartz crystals, consistently aligned along the stone's natural grain direction. Quartz is the most practically significant piezoelectric mineral in the natural world. Aligned quartz crystals, when subjected to mechanical stress, generate electrical current in a specific direction, the direction of the crystal alignment. Stone blocks with well-aligned quartz generate more directional current than stone with random crystal orientation. The Gebel el-Silsila stone was selected for qualities that have no significance for a purely decorative or structural application, but have very significant implications for a building designed to collect and channel electrical potential. Throughout the temple, wherever two large stone blocks meet, they are joined by copper clamps, U-shaped metal connectors sunk into precisely cut channels across the joint between the blocks. Copper is the most electrically conductive metal readily available to the ancient Egyptians. The architectural use of metal clamps to prevent seismic displacement is well documented in ancient construction. What is unusual at Dendera is the pattern of the clamp placement. When the positions of all the copper clamps in the main temple structure are mapped onto a floor plan, they do not distribute randomly or uniformly. They trace specific pathways through the building's fabric pathways that follow the same routes as the conductive plaster channels and the alignment direction of the piezoelectric sandstone blocks. Individually, each clamp is a structural fastener. Collectively, mapped together, they form a network. And then there is the plaster. The wall plaster of the Dendera crypts has been subjected to chemical analysis, and the results include a finding that no standard architectural chemistry can explain. The plaster contains magnetite in concentrations far above what would be present by chance in any normally formulated gypsum mixture. Magnetite is a magnetic iron oxide. It has essentially no aesthetic function. It does not improve the appearance of a plastered surface. What it does, definitively and measurably, is increase the electrical conductivity of the plaster matrix significantly above that of plain gypsum. The Dendera crypt walls were specifically formulated, at meaningful additional cost and effort, to be electrically conductive surfaces. If you were designing a building to collect geological electrical current, channel it through a stone and metal distribution network, and deliver it efficiently to a specific room, you would not change a single material choice that the builders of Dendera made. A building is a three-dimensional object, but its function is often determined as much by the relationships between its parts as by the properties of those parts individually. The way spaces connect, the geometry of how structures are oriented relative to each other and to external reference points, the distribution of specific materials across the building's volume. These are the architectural decisions that define what a building actually does rather than what it merely appears to be. When an electrical engineer named Lane Little spent 2 years systematically mapping the conductive materials of the Temple of Dendera onto its floor plan, he was not approaching the building as architecture. He was approaching it as a circuit. What he found, when the positions of copper clamps, magnetite-enriched plaster surfaces, and piezoelectric stone formations were plotted simultaneously, was that they did not distribute randomly through the structure. They connected. From the outer perimeter of the temple enclosure, where copper clamps in the outer wall formed a roughly continuous loop, conductive pathways traced inward through the building's fabric, following a course consistent with progressive voltage concentration, the architectural equivalent of a step-up transformer, accumulating potential as the pathway moved from the outer structure toward the building's interior core. The pathway led, through the distribution of materials and their geometric arrangement, to the outer walls of the crypt complex. And within the crypt complex, the conductive plaster coverage reached its maximum density in the areas immediately adjacent to the relief panels depicting the discharge devices. The orientation of the temple relative to magnetic north is not what would be expected from a purely astronomical alignment. The building deviates from true north by approximately 2.5 degrees, a deviation present across multiple Egyptian temple sites, noted by surveyors, but rarely explained satisfactorily. Electromagnetic theory provides an explanation that astronomical frameworks cannot. In the geological context of the Nile Valley, an angular deviation of approximately this magnitude from magnetic north would orient a conductive structure to maximize its coupling with the dominant direction of telluric current flow through the regional bedrock. The temples were not oriented slightly away from north by accident or imprecision. They were oriented deliberately towards something that standard astronomical alignment frameworks do not account for. The crypts themselves complete the picture. They are positioned at the base of the outer walls, directly above the bedrock interface, the zone of maximum telluric current density. Their stone floors are bare rock, or close to it, the most direct available connection to the geological current source below. The narrow stone passages connecting the crypts to the temple above them follow the same conductive pathways identified in the floor plan analysis. Buildings designed for worship do not need to make these choices. Buildings designed for worship do not choose specific stone, quarried hundreds of miles away for its mineral alignment. Buildings designed for worship do not formulate their wall plaster with conductive iron ore. Only buildings designed to work do. The floor plan argument also connects to a specific feature of the temple's construction sequence that most architectural descriptions overlook. The crypts at Dendera were constructed before the main temple superstructure was built above them. This is documented in the construction records, and it is unusual. Most crypts in Egyptian temples are afterthoughts, added to existing structures or constructed simultaneously with their surface-level counterparts. At Dendera, the underground technical spaces were the first priority. The building was constructed around the crypts, not the other way around. This sequencing makes no sense if the crypts are merely storage rooms or symbolic spaces subordinate to the main religious functions of the temple. It makes considerable sense if the crypts are the operational core of the building, the rooms whose precise positioning relative to the geology and whose specific material properties determined the architectural decisions made for the entire structure above them. The temple was built to serve the crypts. The crypts were the purpose. Ancient Egyptian ritual is typically understood as performance, the enactment of cosmic narrative through prescribed gesture, recitation, and the manipulation of symbolic objects. This understanding is accurate for the majority of Egyptian ceremonial life. But when the ritual texts of the Dendera temple are examined alongside the material and architectural evidence gathered in the preceding sections, a different possibility emerges: that some of what the priests called ritual was, at the operational level, simply work. The sacred language was the technical manual. The ceremony was the procedure. The texts inscribed in the Dendera crypts and in the library associated with the temple include a series of operational sequences described in the voice of priestly instruction. These sequences use verbs of placement, connection, and activation. They describe specific objects being moved to specific positions, connected to specific other objects in specific ways, and then activated through a sequence of steps that produces a stated result. The result, in multiple texts, is described as the presence of a sustained, unwavering light in the crypt chambers. Not the flickering light of a torch, not the moving light of a carried lamp, but a stable illumination that lasts for a prescribed period and then fades as the operational sequence is reversed. The operational language maps onto the electrical hypothesis with an accuracy that is difficult to attribute to coincidence. Place the serpent in the lotus body describes the insertion of a discharge element into its terminal housing. Connect the pillar of stability describes the engagement of the insulating standoff between the device and its power supply. Allow the force of Ra to pass from the hidden place into the open place describes the completion of an electrical circuit through the distribution system, from the crypt walls to the device. Release the force back into the stone when the work is complete describes the controlled discharge and shutdown of the system. The priests performed these sequences at specific times. Temple calendars from the Dendera complex, cross-referenced with astronomical data, show that the most significant underground rituals were scheduled during a specific season, corresponding closely to the annual peak of the Nile flood cycle, precisely the period when, as the previous chapter established, telluric current activity beneath the temple would have been at its annual maximum. The rituals were scheduled not by religious tradition alone, but, it appears, by power availability. And then there is the clothing. The ritual garments prescribed for priests performing procedures in the Dendera crypts specify dry white linen, with sandals of a specific non-conductive material. Dry linen has very high electrical resistance. It does not conduct current the way damp fabric does. Specific sandal materials with insulating properties are described as mandatory for the ceremony in question. Egyptian priestly dress varied by ceremony, and the rationale for most garment specifications is transparently symbolic: the color, the cut, the material evoking theological associations. For the crypt ceremonies, the specifications make no symbolic sense whatsoever. They make perfect practical sense. The priests who worked in those rooms were wearing protective gear. They were dressing not for a performance, but for a procedure, We do not find it strange when an electrical engineer wears insulating gloves. We only find it strange when the same behavior appears 3,000 years ago, described in a different language, under a different name. When we picture an ancient Egyptian priest, we tend to imagine someone primarily religious, in the contemporary sense, a figure engaged with the divine, mediating between the human and the supernatural, managing the elaborate drama of a theological tradition. This picture is not entirely wrong, but it is radically incomplete. The priests of the major Egyptian temples were, in functional terms, members of a technical order, a hierarchically organized institution that possessed specific operational knowledge, transmitted that knowledge through a structured curriculum, and maintained its authority precisely by ensuring that the knowledge remained within the order's exclusive control. The evidence for this is not speculative. The temple texts themselves describe the priestly hierarchy in terms that leave little ambiguity about the practical nature of the roles involved. At the lowest level of the system, the Wub priests, whose title translates literally as the Pure Ones, were responsible for the physical maintenance of the temple, cleaning, repair, the management of the physical environment in which the higher functions of the institution took place. Above them, the Hermetic priests performed specific ritual procedures according to strictly prescribed sequences. They were the operational staff trained to execute defined procedures, without necessarily understanding the deeper principles behind them. Above the Hermetic priests, the Keriheb, the lector priests, held the textual knowledge that defined the procedures. They read from the sacred books during operations. They directed the operational staff. Their role was explicitly intellectual. They understood the written record of the institution's technical heritage. And at the apex of the hierarchy, the Iripat, the hereditary nobility of the priesthood, held the knowledge that was not written down at all, or was written in such technically specific or encrypted form that the writing itself required expert interpretation to apply. This was the knowledge transmitted not through reading, but through supervised practice, direct experience, and the kind of hands-on learning that modern institutions would call apprenticeship. Temple records from the later periods of Egyptian history describe candidates for the upper priesthood undergoing training periods of extraordinary length, 5 to 10 years of supervised work before being entrusted with the operation of the temple's most sensitive instruments. 5 to 10 years is not the training period for someone learning to perform a ceremony. It is the training period for someone learning to operate complex equipment safely and effectively. The distinction is not subtle. Secrecy was not merely a cultural preference of the Egyptian priestly orders. It was enforced by institutional power. Temple law at Dendera and at other major sites explicitly prescribed death for the unauthorized disclosure of specific categories of technical knowledge. The categories described in the temple texts as hidden things or secrets of heaven. Religious traditions rarely require capital punishment for theological disclosure. Technical institutions, whose competitive advantage depends on exclusive knowledge, do. The analogy to modern technical institutions is not merely rhetorical. Consider the organizational structure of, for example, a pharmaceutical research company, or a classified government laboratory, or a university medical center. In each case, there is a hierarchy of knowledge access. Junior staff perform defined tasks without access to the full institutional methodology. Mid-level staff understand enough to supervise but not to innovate. Senior researchers hold the complete framework. Knowledge transmission occurs through formal training structures that cannot be shortcut because the knowledge in question is not primarily verbal or textual, it is practical, built through supervised experience with the actual materials and processes involved. Institutional secrecy is enforced through legal and contractual means. And the value of the institution to its sponsor depends directly on its maintenance of exclusive possession of the critical technical knowledge. Every one of these features is present in the documented structure of the Dendera priestly order. The continuity between ancient institutional technical knowledge management and modern institutional technical knowledge management is not a metaphor. It is a description of the same fundamental human organizational strategy applied across a distance of 3,000 years. The knowledge held by the Dendera priestly order did not survive intact to the present. This is not a controversial claim, it is one of the most thoroughly documented losses in the history of human civilization. What is less commonly examined is the specific sequence of events that caused the loss, because the sequence is not a story of one catastrophe, but of three successive disruptions, each of which stripped away a different layer of the system that had preserved the knowledge for centuries. The first disruption arrived with Alexander the Great in 332 BCE. The Egyptian priestly orders did not disappear overnight when the Greeks arrived, but the administrative structure of the country changed in ways that gradually undermined the institutional continuity on which knowledge transmission depended. Greek-educated administrators gained access to temple resources and libraries. They could read translations of temple texts, but lacked the practical training, the supervised apprenticeship of years, that would have allowed them to understand what those texts were actually describing. The Temple of Dendera was rebuilt and expanded during the Ptolemaic period that followed Alexander's conquest. The reliefs in the crypts that survive today are Ptolemaic copies of older originals. Ptolemaic priests carved images they may have been reproducing from much earlier sources without fully understanding what those images originally depicted. They preserved the form while possibly losing the function like scribes, faithfully copying a wiring diagram in a language they can read but cannot practice. The second disruption was the Roman conquest of Egypt in 30 BCE, which ended the Ptolemaic dynasty and introduced an administration primarily interested in Egypt as an economic asset. The systematic Roman practice of converting conquered temple treasuries into coinage, melting down gold and copper objects, and minting them as portable wealth would have eliminated exactly the kinds of conductive metal objects that the electrical hypothesis requires: the storage devices, the connecting components, the physical apparatus described in the temple texts as possessing unusual properties. If those objects existed, the Romans would have melted them. The historical record of this process is not speculative. It is the documented pattern of Roman imperial resource extraction applied to conquered temples across the Mediterranean world. The third disruption was the Edict of Thessalonica in 380 CE, which made Christianity the official religion of the Roman Empire and led to the formal closure of Egypt's remaining active temples. The disbanding of the surviving priestly orders and the physical conversion of temple spaces to Christian use severed the last institutional thread by which operational knowledge might have been maintained. And within a single generation of that closure, something happened that remains one of the most significant intellectual losses in recorded history. The knowledge of how to read hieroglyphic script disappeared entirely. The last known hieroglyphic inscription was carved in 394 CE. Within 30 years, no living person on Earth could read it. Whatever the Dendera priests had written about their system, every procedure, every material specification, every operational instruction became completely unreadable for the next 1500 years. Knowledge is more resilient than the institutions that protect it. When the library burns, the librarians have already memorized the essential books. When the temple closes, the priests have already encoded the critical procedures in other forms, other languages, other traditions that will survive the specific catastrophe currently approaching. The question of whether the Dendera technical knowledge was entirely extinguished, whether every trace vanished when the last hieroglyphic inscription was carved, is one that the historical record answers with considerable ambiguity. The Library of Alexandria was founded in 331 BCE, less than 100 miles from Dendera, at the precise moment when Greek administration was beginning to absorb Egyptian institutional knowledge. Early accounts of the library's holdings describe, alongside the classical texts in philosophy and literature that made the institution famous, a collection of temple scrolls acquired from major Egyptian religious sites. The holdings of the Dendera Parank were among those specifically referenced in ancient descriptions of the library's acquisitions. Within the library, a category of texts described as sacred mechanics. Documents describing the construction and operation of temple devices was reportedly translated into Greek and preserved in a restricted section, accessible only to senior scholars. This restricted collection is not the library's famous open collection. Whatever the sacred mechanics texts contained, someone decided they should not be widely read. The tradition of Hermeticism that emerged from Alexandria in the 1st through 3rd centuries CE is recognized by modern scholarship as a synthesis of Greek philosophical method and Egyptian temple knowledge. The Hermetic texts attributed to the legendary figure Hermes Trismegistus, whose name translates as thrice greatest. Hermes contain passages that describe the manipulation of what they call subtle fire, the illumination produced by the serpent of force when properly contained, and the relationship between earthly and atmospheric electrical phenomena in terms that align closely with the content of the Dendera crypt inscriptions. These texts survived through the medieval Islamic world and into Renaissance Europe, where they were read with intense interest by natural philosophers who regarded them as genuine remnants of ancient technical wisdom. Among those who read Hermetic texts carefully was Nikola Tesla. Tesla's personal library and notebooks contain references to ancient technical traditions and specific notations about the possibility that electrical principles were known before their official discovery. One notation, reproduced in secondary sources, reads in summary: "The ancients understood the earth as a source. We are not inventors of electrical science. We are recoverers of it." Tesla designed the Wardenclyffe Tower as a device for drawing electrical power from the Earth's natural field, a concept structurally identical to the Dendera system's relationship with telluric currents. Whether Tesla arrived at this concept independently or through the Hermetic transmission stretching back to Alexandria, the convergence is specific enough to demand attention. The connection may be coincidence, but coincidence of this precision, applied to this subject in this sequence, is a very specific kind of coincidence. The phrase hidden microgrid sounds dramatic, possibly conspiratorial, certainly unusual when applied to an ancient Egyptian temple. Before the hypothesis can be evaluated fairly, its terms need to be precisely defined, not to make the idea sound more legitimate than it is, but because precision is the tool that separates a serious proposal from a sensational one. This investigation intends to be serious. A microgrid, in modern electrical engineering, is a defined and bounded local power system that generates, stores, and distributes electrical energy within a specific physical boundary, independent of any larger external network. The key functional elements are simple and can be stated plainly. First, there is a local source, some mechanism by which electrical energy is generated within or collected from the immediate environment of the system. Second, there is a distribution pathway, the conductors, channels, or materials through which generated energy moves from its source toward its destination. Third, there is storage, some means of accumulating charge, so that energy can be available when needed, rather than only when the source happens to be producing at peak capacity. Fourth, there are loads devices that consume the electrical energy and produce a useful result from it. The preceding chapters have systematically examined evidence for all four of these components in relation to the Temple of Dendera. The local source is telluric current, generated through the piezoelectric activity of the quartz-bearing sandstone under the mechanical stress of the Nile flood cycle, amplified by the atmospheric charge differential available across the temple's vertical extent. The distribution pathway is the network of copper clamps, magnetically enhanced plaster surfaces, and aligned piezoelectric stone that the floor plan analysis identified as tracing specific conductive channels through the building's fabric. The storage is the metal objects described in temple texts as having the capacity to retain the force of the god objects, whose descriptions correspond to capacitive storage devices, whose materials had high electrical conductivity, and whose periodic charging in the crypt chambers was the explicit purpose of the most restricted ritual procedures. The loads are the discharge tubes depicted in the crypt reliefs, glass vessels containing specific gas mixtures, configured to produce luminous electrical discharge when supplied with sufficient voltage. This is not a wild speculation about ancient super technology. It does not require hidden civilizations or any principle of physics not already well established. It requires only that a civilization sophisticated enough to practice brain surgery, synthesize precision pigments, and engineer acoustic resonance chambers, also possessed by deliberate development or by inherited tradition, an understanding of the electrical properties of geological materials and the physics of gaseous discharge. That civilization demonstrably existed. The building demonstrably has the structural and material properties described. The images demonstrably exist. The system described would have needed less electrical power to operate than a modern household refrigerator. The question is not whether it was physically possible. The question is whether it happened. One further analogy helps clarify the scale and plausibility of the system. Modern portable solar energy systems, used in remote areas running a few LED lights, a small water pump, and a radio operate on power budgets in the range of 20 to 100 watts. A single discharge tube in a compact sealed crypt, glowing at the intensity depicted in the Dendera reliefs, would consume a comparable amount of power. The difference between a solar panel and the Dendera collection system is not a difference in the scale of power required. It is a difference in the collection mechanism. Solar panels convert photons to electrons with very high efficiency. A telluric current collection system converts geological pressure to electrons with lower efficiency and through a much slower accumulation process. But the accumulation can happen continuously, over days and weeks, with the charge stored in capacitive metal objects until the moment it is needed. The system does not need to generate and consume power simultaneously. It needs to generate and store over time, then discharge when the charge is sufficient. This is the fundamental design logic of any battery-powered device. It is also, precisely, the design logic of the Dendera operational system, as described in the ritual texts. The force accumulates in the hidden place until the ritual season, at which point it is sufficient for the ceremony. The power source of the Dendera microgrid begins underground, not in the crypts, but deeper than the crypts, in the bedrock beneath the temple's foundations, where the geological conditions of the Nile Valley produce the specific electrical phenomena that make the hypothesis viable. To understand how the power may have worked, it helps to follow the energy from its origin, through its transformation and accumulation, through the building's structure, to its eventual application in the discharge device. The path is not long. It follows natural principles that can be verified with modern instruments. What makes it extraordinary is that someone appears to have understood and exploited these principles more than 3,000 years before the physics describing them was formally written down. The Dendera region sits on a northeast to southwest fault zone, a fracture in the bedrock where two sections of the Earth's crust are in continuous, slow, relative motion. Fault zones under compressive stress generate piezoelectric current in quartz-bearing rock continuously because the stress that drives the fault motion also continuously loads and unloads the crystals along the fault plane. The sandstone formations of the Gebel El Silsila quarry, with their unusually high and well-aligned quartz content, translate this geological stress into directional electrical current more efficiently than most rock types. Modern geological surveys of the Dendera region have measured telluric current densities significantly above the regional baseline in exactly the areas where the fault zone passes beneath the temple site. The annual Nile flood adds a second, cyclical layer to this steady-state current. As the flood waters rise in midsummer, the enormous additional weight of water-saturated soil across the Nile Valley creates a seasonal compression event for the underlying rock. This compression peaks when the flood is at its highest, amplifying the piezoelectric current generation in the bedrock by a factor that depends on the flood's intensity, but is always substantial. Temple records consistently identify the peak ritual season in the Dendera crypts as occurring at the time of maximum inundation. This is a curious scheduling choice from a purely liturgical perspective. The peak flood period was also the period of maximum agricultural disruption and maximum logistical difficulty for everything else. From an electrical perspective, it is the only scheduling choice that makes sense. The power was most available at peak flood, so the procedures requiring power were performed at peak flood. Ancient texts preserved through Hermetic and Coptic transmission describe this seasonal pattern with a directness that resists symbolic interpretation. The force is strongest when the great river rises. The light in the lower rooms is most complete at the time of the inundation. These are not metaphors about spiritual abundance. They are operational notes about power, availability, and its relationship to a predictable natural phenomenon. Tesla's Wardenclyffe Tower, designed in 1901, proposed to accomplish at commercial scale exactly what this analysis suggests. The Dendera system accomplished at ritual scale, draw electrical potential from the Earth's natural field through a structure built to couple efficiently with that field, concentrate it through the building's geometry, and deliver it to specific load points for specific applications. The Wardenclyffe schematic, when scaled down to the dimensions of the Dendera temple and adjusted for the differences between a modern electrical transmission tower and an ancient stone building, produces a structural configuration that is specifically similar to the Dendera floor plan. Not casually similar, but similar in the same way that two buildings following the same engineering logic are similar. They make the same choices because those choices are the correct choices for the function being served. Tesla built Wardenclyffe in 1901, after writing notes about the ancients having known the machines. Whether those notes reflected genuine historical knowledge or independent convergence, the structural parallel between his unbuilt tower and the ancient temple that preceded it by 3,000 years is one of this investigation's most genuinely striking details. Starting at the outermost walls of the Dendera enclosure and following the conductive materials through the building to their terminus in the crypt relief panels is an exercise that begins to feel, at a certain point, less like architectural analysis and more like following a carefully laid trail. The outer enclosure wall contains copper clamps at regular intervals. The clamps trace a roughly continuous loop around the perimeter of the entire complex. A loop of conductive material at the outermost boundary of a structure is, in electrical engineering, an antenna, a collector of electromagnetic energy, coupling the structure to the energy field that surrounds it. The loop does not capture energy in large quantities from ambient electromagnetic radiation, but telluric currents, which flow through the ground and couple into any conductive structure that makes good contact with it, are a different matter. A conductive perimeter loop with deep foundation contact points is an efficient telluric current collector. The outer wall of Dendera, with its copper-clamped sandstone perimeter and deep bedrock footings, is structured exactly like one. From the outer loop, the distribution pathway moves inward. The copper clamps that join the outer wall blocks appear also in the walls of the hypostyle hall, the main covered space of the temple, but not uniformly distributed. They concentrate along specific pathways that run parallel to the long axis of the building, from the outer walls toward the sanctuary complex at the temple's core. These pathways correspond to the current direction that would be induced by telluric flow from the primary fault zone beneath the site. The clamp distribution is not random. It follows the geology. The stone conduits in the interior walls have been classified in Egyptological literature as drainage channels. This classification presents an immediate difficulty. Several of them are located well above the floor level, at heights where water would not naturally accumulate and from which drainage would serve no architectural purpose. Their dimensions narrow, smooth-walled, oriented vertically, or on shallow angles, are consistent with a conduit designed to channel something other than water. Their positions within the wall structure, appearing most frequently in the sections of wall that the floor plan analysis identified as carrying the main conductive pathways, suggest they are not drainage features, but components of the same distribution system. Within the crypt complex itself, the character of the materials changes abruptly and significantly. The conductive plaster coverage increases dramatically at the transition from the upper temple to the underground chambers. The metallic mineral concentration in the plaster matrix is measurably higher in the crypt walls than anywhere else in the building. The bare rock floor of the crypts provides direct bedrock contact, the most immediate possible interface with the telluric current source below. And the wall surfaces immediately adjacent to the three lamp relief panels show, under microscopic analysis, an unusually high concentration of microcrystalline metal inclusions in the plaster inclusions, whose distribution, when mapped, corresponds to the positions where a discharge device of the depicted dimensions would need to make electrical contact with its support wall. Follow the copper clamps from the outer wall inward. Follow the conductive plaster from the interior corridors downward. Follow the metal inclusions in the crypt walls toward the relief panel. At that panel, connected to the distribution network by the insulating DJ'd pillar, receiving current from the plaster matrix at its two terminal points, the device depicted would glow. Not metaphorically, electrically. The trail of materials leads to one conclusion. It is not a trail, it is a wire. The most powerful objection to the Dendera electricity hypothesis is produced by the simplest questions. Where is the evidence? Where are the glass tubes? Where are the metal storage devices? Where is a single physical artifact that can be held up and identified as a component of an ancient electrical apparatus. The objection is real. The absence of physical objects is a genuine evidentiary problem that any serious treatment of this hypothesis must address directly, rather than slide past with references to interesting reliefs and suggestive geology. The first part of the answer involves the documented fate of the temple's movable contents. Temple inventories from the later periods of Dendera's active life describe the crypts as housing dozens of sacred metal objects, statues, vessels, tools, and instruments made from gold, copper, and compounds of both. These objects were described as possessing unusual properties. They were stored under strict security, handled only by initiated priests, and never placed on public display. When the Roman administration assumed control of Egypt in 30 BCE, the systematic extraction of temple wealth began almost immediately. The Roman treasury needed metal, and the temples of Egypt were among the richest concentrations of metal objects in the ancient world. Gold and copper objects from temples throughout the country were systematically removed over the following centuries, melted down, and converted to coinage or imperial plate. The specific objects described in Dendera temple inventories are not present in any museum collection and have not been found at the site. They were removed. The historical record of their removal is not speculative. It is the documented pattern of Roman imperial resource extraction. The glass components of the hypothetical discharge devices present a different but related problem. Ancient glass is fragile and chemically reactive over long timescales. Even glass objects of significant size and cultural importance are rarely recovered intact from the ancient world. When found, they are typically in fragments or significantly degraded. Sealed glass vessels removed from a protected crypt, transported, and stored under unknown conditions after the temple's closure would have minimal survival probability over 2,000 years. What remains is the building itself, the structure, the materials, the geometry, the texts carved into the walls. This is what could not be carried away and melted down. This is what the Romans and the Christians and the French could not entirely erase, though all three attempted in different ways to diminish it. The physical system is gone. The blueprint for the physical system is still there, carved in the most protected room in one of the most durable structures the ancient world produced. The absence of the devices is fully explicable by documented historical processes. The persistence of the blueprint is the evidence. There is no conspiracy to suppress the Dendera electricity hypothesis. This is worth stating plainly, because the hypothesis has attracted conspiracy-minded commentary, and that commentary has done it considerable damage with the academic community. The reason the electricity hypothesis has not been seriously investigated by mainstream Egyptology is not that powerful forces are hiding the truth. The reason is considerably more mundane and considerably more instructive about how knowledge systems actually work. Egyptology is a discipline with defined methodological boundaries. Egyptologists are trained to read ancient Egyptian texts, to analyze material culture in the context of Egyptian historical and religious traditions, and to situate individual artifacts and sites within the larger narrative of Egyptian civilizational development. These are genuine skills requiring years of specialized study, and the people who hold them are generally rigorous and intellectually honest within the framework their discipline provides. What the discipline's framework does not include is electrical engineering. It does not include geophysics. It does not include the materials science needed to interpret the significance of magnetite-enriched plaster, or the structural analysis needed to read a circuit layout in a floor plan. The electricity hypothesis is, at its core, an interdisciplinary question. It requires Egyptological expertise to read the texts, electrical engineering knowledge to interpret the structural details, geophysical training to assess the geological power source, and materials science competence to evaluate the compositional choices. Individuals who hold all four of these qualifications simultaneously are essentially non-existent. The hypothesis therefore falls into the gap between disciplines. It is not quite the problem of any one field, and each field that encounters it tends to refer it to another. The second structural barrier is what might be called fringe contamination. In the 1990s and early 2000s, the Dendera lamp image became a staple of the ancient aliens genre, a body of popular literature and television content characterized by low evidentiary standards and a tendency toward sensational claims. Serious researchers who might otherwise have engaged with the electrical hypothesis carefully became reluctant to do so publicly, because engagement with the topic risked professional association with a tradition of inquiry they rightly regarded as methodologically poor. A German engineer named Reinhard Habeck produced a technical analysis of the Dendera reliefs that was substantive, well-referenced, and written in the language of electrical engineering rather than ancient mystery. He found no Egyptological journal willing to review it because he was not a credentialed Egyptologist. He found no engineering journal willing to review it because it concerned ancient Egypt rather than modern technology. His analysis exists in a liminal space where no institutional jurisdiction clearly applies, which is, in practice, the same as not existing at all within the formal research literature. The problem is not suppression. The problem is that the question does not fit the shape of any existing institution. The fringe contamination problem is not unique to the Dendera hypothesis. It has affected multiple legitimate areas of inquiry that happen to overlap with the popular ancient mysteries genre. The serious scientific debate about the age of the Sphinx was significantly delayed by the association of early geological arguments with non-scholarly presentations of the same conclusions. Serious research into the acoustic properties of Stone Age megalithic sites was initially dismissed partly because of the subject's popularity in alternative spirituality circles. In each case, the association with popular mysticism did not make the underlying technical questions less legitimate. It made them harder to ask in a professional context, because the professional cost of asking them was artificially elevated by the reputational contamination. The Dendera electricity hypothesis is in exactly this position. The question is legitimate. The evidence is specific. The technical tools to evaluate it exist and are in routine use at other sites. What is lacking is the institutional willingness to ask the question publicly, in a professional context, with the credibility that would ensure the results are taken seriously regardless of what they show. The crypts are not the only part of the Temple of Dendera that carries information relevant to this investigation. The pronaos, the large covered entrance hall of the main temple, is roofed with one of the most extraordinary astronomical ceilings of the ancient world. The famous Dendera zodiac, removed by French archaeologists in the 19th century and now in the Louvre, represents only one portion of this ceiling's content. The pronaos ceiling that remains in place is less frequently discussed, but arguably more significant for this investigation. This ceiling is divided into bands corresponding to different aspects of the Egyptian astronomical and cosmological system. The outermost band contains the familiar Egyptian constellations and celestial markers. The inner bands move progressively deeper into the Egyptian understanding of the relationship between celestial and terrestrial forces. And in several positions within the zodiacal band, at regular intervals that correspond to specific seasons, there are images that do not fit the conventional repertoire of Egyptian astronomical notation. These images show luminous phenomena that extend across regions of the night sky in sweeping, curved forms, moving from one horizon area toward another. The movement patterns depicted are not the orbital paths of planets. They are not comet trails, which the Egyptians depicted in other contexts with specific visual conventions not used here. They closely resemble depictions of auroral displays, the patterns of light produced in the upper atmosphere when charged particles from solar events interact with the Earth's magnetic field and produce the phenomenon we call the Northern Lights. The Northern Lights are not visible from Egypt under ordinary atmospheric conditions. They can be observed in Egypt during extreme geomagnetic storms, the kind produced by Carrington-scale solar events that occur once every few centuries. The Egyptians tracked the sky with obsessive and continuous attention. If such an event occurred and produced visible aurora over Egypt, they would have recorded it, and the visual language they would have used for sustained, luminous atmospheric phenomena would look exactly like these ceiling images. But here is what makes this significant beyond mere astronomical curiosity. The aurora is a direct visual expression of the same ionospheric charge differential that the Dendera system appears to have been designed to exploit. The lights in the sky that the Dendera priests recorded on their ceiling are produced by the same physical mechanism that charged the ground beneath their temple. One specific panel of the astronomical ceiling depicts what appears to be a discharge arc between two celestial bodies. Imagery that, in the context of this investigation's accumulating argument, lands with the force of a final puzzle piece clicking into place. The priests who depicted the aurora borealis above their discharge tube reliefs were not making an unrelated artistic choice. They were showing two manifestations of the same force, the force in the sky and the force underground. The connection between them was not mystical, it was physical, and they knew it. If light was produced in the underground chambers of the Temple of Dendera through electrical means, the question that follows immediately is, why? What was the light for? The most popular answer in alternative history discussions is practical illumination. The artists who carved the extraordinary reliefs in the crypts needed light to work by, and an oil lamp-free light source would have avoided the soot accumulation that conventionally lit ancient painters had to contend with. This explanation is partially correct, and the evidence for it is, in fact, quite strong. The Dendera crypts show no soot deposits on their upper surfaces. Sustained illumination of an enclosed space by oil lamps produces visible dark staining on ceilings and upper walls. This pattern is consistently observed in ancient spaces where lamplit work was conducted over extended periods. The Dendera crypts do not show this pattern, despite containing carvings of extraordinary detail, a number that would have required many hundreds of hours of sustained illumination during their creation. Either the reliefs were carved in darkness, which is not physically possible for work of this precision, or they were carved using a light source that produced no combustion products. The soot evidence, or rather its complete absence, is a specific and measurable form of support for the electrical hypothesis. But the carving explanation, while valid, feels like a modest justification for an elaborate system. The architectural complexity of the conductive material network, the precision of the geological positioning, the detailed ritual procedures described in the temple texts, all of this is a great deal of investment for a workshop lighting arrangement. Ancient painters solved the problem of underground illumination at many other sites with reflective metal plates and repositionable oil lamps. The sophistication of the Dendera system implies an application beyond painting convenience. The temple texts describe the crypts as places where sacred objects were charged, filled with the power of the god. These charged objects were then carried out of the crypts and into ritual spaces where they were displayed and placed in proximity to worshippers and petitioners. The specific effects attributed to these charged objects include the ability to produce sparks when touched, to attract small lightweight materials, and to produce a faint visible glow on their surfaces in otherwise dark conditions. These are the effects produced by a highly charged electrostatic capacitor. An object given a high electrostatic charge will produce sparks on contact with a grounded conductor, attract particles through electrostatic induction, and under certain conditions produce a dimly visible surface discharge. The charged sacred objects were portable demonstrations of a phenomenon that the priestly class understood, could reproduce on command, and could present as evidence of divine presence to an uninitiated audience experiencing it for the first time. The technology was not merely a tool, it was the foundation of institutional authority. There is a sociological parallel here that contemporary audiences will recognize without difficulty. The modern consumer electronics industry runs partly on the same principle that the Dendera priestly order appears to have employed. The exclusive possession of technology that produces effects incomprehensible to those who lack the knowledge to understand it is a source of social authority, economic value, and institutional power. We do not find it strange that a company whose engineers understand quantum tunneling in semiconductor junctions can produce devices that appear magical to the majority of their users. We do not call the company's engineers priests. But the structural relationship between exclusive technical knowledge, impressive demonstrations of that knowledge, and the institutional power those demonstrations confer is identical to the relationship described in the Dendera temple texts. The priests charged the sacred objects in the crypt, carried them into the public spaces of the temple, and demonstrated their properties to worshippers who experienced them as the direct action of the divine. The technology was the basis of belief. Belief was the basis of authority. Authority was the basis of the institutional resources that maintained the technology. The loop is closed. It is also completely familiar. One of the most persistent conceptual difficulties in discussing the Dendera electrical hypothesis is the framework that contemporary thought brings to the words technology and religion. In our world, these are distinct categories. Technology is what engineers do. Religion is what priests do. The fact that both activities take place in large, impressive buildings does not make them the same activity, and the suggestion that a temple might also be a functional electrical system strikes many people as a category error, an absurd merging of two things that self-evidently belong to different spheres of human activity. This framework is not universal. It is a specific product of a specific intellectual history that separated natural philosophy from theology in the 17th century, and completed that separation with the development of professional scientific institutions in the post-19th. Before that separation, and in cultures whose intellectual histories did not follow the same trajectory, the distinction between understanding how the world works and understanding what the world means was not a clear or important boundary. It was, in many traditions, not a boundary at all. Ancient Egyptian thought was organized around the concept of ma'at, a word usually translated as truth or cosmic order, but whose meaning encompasses both the descriptive truth of how things actually are and the prescriptive truth of how things ought to be. For the Egyptians, a priest who understood the true nature of a natural force and could demonstrate that understanding through practical application was not a scientist who had disguised his work as religion. He was a religious practitioner whose spiritual understanding had reached the level at which it became operational. Knowledge of the real world, in the Egyptian framework, was the highest form of spiritual attainment. The deeper you understood reality, the closer you were to the divine order that structured it. The Egyptian word heka, typically translated as magic, carries a more specific technical meaning than that translation implies. Heka is the activation of the ka, the activation of the life force inherent in a thing, the use of correct knowledge and correct procedure to cause the inherent power of a substance, a configuration, or a relationship to become effective and observable in the world. When an Egyptian text describes a priest performing heka, it is not describing an illusionist producing a theatrical effect. It is describing a practitioner with sufficient knowledge to cause a real physical effect through the application of real physical principles. The difference between heka and what we would call applied physics is not a difference of substance. It is a difference of cultural vocabulary. In this context, the Dendera electrical system is not a strange hybrid of science and religion. It is an entirely coherent product of a tradition in which the distinction between science and religion did not exist, where the deepest technical knowledge was inseparable from the deepest spiritual understanding, and where demonstrating mastery over natural forces was the most compelling proof of genuine contact with the divine. In the hours before the ritual began, the approach to the temple would have carried the particular quality of late summer desert air at the height of the Nile flood, heavier than usual, carrying the smell of river silt and the faint undertone of the specific resin that the temple texts prescribe for burning in the crypts during operational periods. This resin, identifiable by its description in temple records as a compound derived from the acacia tree, contains concentrations of aromatic terpenes that heighten sensory sensitivity and amplify the perception of subtle stimuli. The practical effect of burning it in an enclosed space where unusual sensory experiences were about to occur would have been to lower the threshold at which those experiences registered and to intensify their psychological impact on practitioners already conditioned, through years of training, to respond to them as manifestations of the sacred. The entrance to the crypt passage was not marked publicly. The priests who carried the sacred objects into the underground chambers knew which stone to press, which wall panel concealed the passage, how to navigate the narrow descending corridor without stumbling. They would have felt the air change as they descended, not just cooler, but different in the way that spaces with continuous low-level electrical fields feel different from spaces without them. Dry. Charged in the literal sense. Hair follicles responding to gradient changes. The particular atmospheric quality we now recognize as the feeling of proximity to high-voltage equipment, but that these priests had no descriptive language for beyond the language of divine presence. Then, the operational sequence began. The texts describe the placement of the serpent in the lotus body, the connection of the pillar of stability, the opening of the pathway from the hidden place, the connecting of the discharge device to the distribution network, the completion of the circuit from the crypt walls through the insulating standoff to the device terminals, the allowing of the accumulated charge to flow. The discharge would not have been instantaneous. Discharge tubes build gradually when the driving potential rises slowly as telluric current accumulates charge in a capacitive system rather than surging from a direct supply. A faint luminescence at the cathode end first, then the beginning of the characteristic glow along the axial path, progressing as the voltage climbs steadily. The serpent of light taking form inside the glass body, reddish at first, the emission color characteristic of the gas mixture involved, shifting toward the blue-white that sustained discharge produces. The crackling sound that discharge tubes generate, described in the temple texts as the voice of the serpent. The quality of light in the crypt changing from total darkness to the cool, unwavering, shadowless illumination that discharge produces the light that does not flicker, does not smell, does not burn, and was described in the oldest Dendera inscriptions as the light that has always been here, waiting. The charged, sacred objects placed on the conductive surfaces nearby would have responded visibly to the ambient electrical field, attracting particles, producing contact sparks, carrying their invisible force for the journey back to the upper world. And then the sequence reversed. The disconnection, the fading of the glow, the gradual quieting of the serpent's voice, the return of cold and dark, and the silence of stone. The priests withdrew. The passage sealed behind them. The system rested, recharging through the geology beneath it, waiting for the next ritual season when the great river rose again, and the ground filled once more with the force that the priests called the power of the god, and we would call electrical potential. After 9 chapters of evidence, it is worth pausing here at the threshold of conclusions to be completely clear about what this investigation has and has not established. This documentary has not proven that the ancient Egyptians had electricity. It has demonstrated something more specific and, in its own way, more significant, that the evidence for the hypothesis is not the product of wishful thinking or creative misreading. It is specific, material, measurable, and coherent, and it has been systematically avoided by the academic institutions best positioned to evaluate it. What has been demonstrated is that the question deserves serious investigation. What has not been proven is the final answer. There is also a 4th tier worth naming, not an evidentiary tier, but a human one. The people who carved the Dendera reliefs lived full lives in a real world. They woke in the morning, performed their work, ate their meals, and navigated the social and political landscape of one of the most sophisticated civilizations in history. They were not mythological figures. They were not symbols. They were engineers, or something very much like engineers, working within an institution that valued precision and rewarded competence. Whatever they understood about the phenomena they depicted, they understood it well enough to describe it in the most durable medium available, stone in a language precise enough that its structural content survives the loss of its cultural context by 2,000 years, and still speaks clearly to anyone who approaches it without preconceptions. Respecting that achievement does not require accepting every claim made about it. It only requires acknowledging that the people who made it were operating from genuine knowledge of something real, and that our inability to fully read that knowledge yet is a problem for us, not a failing in them. The evidence examined in this investigation organizes itself into 3 clear tiers. The first tier contains the things the evidence genuinely and strongly supports. That the Dendera crypt reliefs depict objects structurally consistent with electrical discharge devices in at least 7 independently verifiable geometric correspondences. That the Temple of Dendera is built from materials with significant and non-accidental electrical properties, piezoelectric sandstone, copper distribution networks, magnetically enhanced wall plaster. That the geological environment of the Dendera site produces measurable telluric current that would be available to an appropriately designed structure, and that the ritual texts of the Dendera temple describe operational sequences whose language maps consistently and specifically onto the management of an electrical system. These are not interpretations imposed on neutral evidence. They are findings that emerge when the evidence is examined through an electrically informed lens. The second tier contains the things the evidence suggests but cannot confirm. that the Egyptians who built and operated Dendera consciously understood the electrical principles at work in their system, rather than having discovered them empirically without any theoretical framework, that the system was operationally functional at some point in the temple's history, rather than merely depicted, and that the technical knowledge represented at Dendera reflects a continuous tradition extending back to a civilization that preceded the pharaonic period. The third tier contains the things the hypothesis requires, but the available evidence does not yet provide. A physical artifact, identifiable as a component of the system. A direct electromagnetic measurement of the conductive pathway through the temple structure, and an explicit textual description of the system that eliminates all symbolic interpretations. These gaps are real. They are also explicable by the documented historical processes of Roman material extraction and the complete loss of hieroglyphic literacy. The honest position is not certainty in either direction. It is the recognition that our picture of the ancient world has gaps large enough to hide entire scientific traditions, and that the institutional machinery we have built to study the ancient world was not designed to look into those gaps. Resolving the Dendera electricity hypothesis does not require exotic technology, colossal excavation, or the dismantling of a priceless ancient structure. The tests that would answer the central questions of this investigation are non-invasive, technically routine, and modest in cost. They have been performed at dozens of archaeological sites around the world. They have simply never been proposed, funded, or conducted at Dendera. The gap between what we know and what we could know is not a technological gap, it is an institutional one. The most immediately valuable investigation would be a comprehensive electromagnetic survey of the Dendera temple complex. Ground-penetrating radar and magnetometry, both non-invasive techniques that do not require a single stone to be touched, moved, or disturbed in any way, would map the distribution of metallic minerals and conductive pathways through the building's fabric and underlying geology, with far greater precision than the fragmentary chemical analyses conducted to date. A magnetometry survey would reveal whether the copper clamp distribution in the walls actually traces continuous conductive pathways of the kind that the floor plan analysis implies. Ground-penetrating radar would characterize the bedrock geology directly beneath the crypt floors and determine whether the structural relationship between the crypts and the underlying fault zone is what the telluric current hypothesis requires. These surveys, conducted at comparable historical sites around the world, typically take 2 to 4 weeks of fieldwork. Their cost, by modern scientific funding standards, is negligible relative to the significance of the question they could answer. The second critical investigation would be a systematic chemical and electrical analysis of the crypt wall plasters, not the fragmentary sampling that has been done in passing, but a comprehensive mapping of the magnetite distribution, the conductivity of the plaster matrix, and the surface chemistry of the wall areas adjacent to the relief panels. Plaster surfaces that have carried sustained electrical discharge for extended periods leave specific chemical signatures, certain oxidation products, certain surface crystalline structures that persist for millennia in sealed environments. If the crypt walls were ever part of a functioning electrical circuit, the chemistry of those specific wall areas will show it. If they were not, the analysis will be negative and the hypothesis will be correspondingly weakened. The test is falsifiable. That is what makes it scientific. The third investigation concerns the relief panels themselves. Modern spectroscopic analysis, again, entirely non-invasive, can determine the exact elemental composition of surface treatments on stone reliefs that are invisible to the naked eye. If the D-jade pillar and lotus-based depictions in the crypt reliefs carry surface treatments of metallic compounds consistent with electrical terminal contacts, that finding would be direct physical evidence of the hypothesis at the most specific level of its claim. These three investigations together would either confirm the core physical structure of the microgrid hypothesis or provide specific, measurable evidence against it. Neither outcome is embarrassing. Both outcomes advance knowledge. The only embarrassing outcome is the one we currently inhabit, a question of this specificity and this significance, resting on evidence this substantial, going untested for decades because no single institution has recognized it as its own responsibility to ask. There is a specific calculation that makes the institutional argument about the surveys particularly pointed. The Egyptian government, through its Supreme Council of Antiquities, has approved non-invasive geophysical surveys at multiple major archaeological sites in recent years, including several surveys specifically designed to identify hidden chambers and subsurface structures. The technology used for these surveys, ground-penetrating radar, electrical resistivity tomography, magnetometry, is exactly the technology that would be most informative applied to the Dendera crypt complex and the bedrock beneath it. The survey of the Great Pyramid of Giza, conducted in 2016, which identified previously unknown voids within the structure, is a direct precedent for the kind of investigation that the Dendera site requires. That survey was conducted, its results published, and its findings incorporated into the scholarly literature about the pyramid within a period of 2 years. The equivalent investigation at Dendera has not been proposed. The absence is not the product of technical limitation. It is the product of the question not having been asked by anyone with the institutional standing to authorize the equipment access. This investigation is, in part, an attempt to contribute to the conditions under which that question might finally be asked. This investigation began with an image on a wall, an elongated oval form, a coiling light inside it, a lotus base, a pillar of stability, 2,000 years of silence around it, and the question of what it means. The question has not been answered definitively in the hours since, but the question has been transformed. It is no longer the small question. It appeared to be at the beginning a question about a curious carving in an Egyptian crypt. It has become a question about the shape of human history itself, about the stories we tell when we look backward at the long record of what human beings have known and built and lost. We live inside a narrative of progress. The standard model of human history is essentially a story of linear ascent, primitive beginnings, incremental accumulation of knowledge, the achievement of civilization, the gradual refinement of understanding, until we arrive at the current moment, which is assumed to be the most advanced point the species has ever occupied. This model is so deeply embedded in contemporary thought that it functions less as a theory than as a background assumption, the unexamined context in which every specific historical claim is understood. Ancient people were less advanced. Modern people are more advanced. The line runs upward and it does not reverse. But if knowledge can be born, developed to extraordinary refinement, institutionally protected for centuries, and then destroyed in a single generation, when the institutions that carried it collapse, if the line does not only run upward but can also fall sharply back, then our understanding of where we are on the curve changes. The electrical knowledge that may have been encoded in the walls of Dendera was not recovered by modern science working consciously from an ancient foundation. Modern science arrived at the same principles independently, following different physical intuitions from different cultural starting points. But if the Egyptians were there first, then what we call discovery was, in specific domains, something closer to remembering the rediscovery of a path that had already been walked and then overgrown. The question this evidence is really asking is not whether the ancients were smarter than us, or whether some secret knowledge was maliciously suppressed, or whether the official history is a fabrication. The question is simpler and more unsettling than any of those. The question is whether the story of human knowledge is a story of continuous accumulation or a story of repeated cycles, whether we have been building steadily upward or whether we have been, in certain domains and at certain times, rebuilding from ruins without knowing they were ruins. Imagine a civilization 20 centuries from now excavating the remains of our cities. Imagine them finding, in a sealed library, a wiring diagram for a smartphone without the smartphone itself. They might call it symbolic art. They might call it a religious image of the connected world. They might debate whether the ancient people who drew it truly understood what it depicted, or merely copied something they could not comprehend. They would almost certainly not conclude immediately that we had portable wireless communication technology, because everything else they found would seem too simple and too impermanent to support that conclusion. They would be wrong, just as we may be wrong, right now, about the light that has been waiting in the dark beneath the Temple of Dendera for more than 2,000 years. The serpent is still coiled in the lotus body. The pillar of stability still rises between the base and the oval vessel. The figures still stand at their careful distances, arms extended, postures unchanged across centuries. The inscription still reads, "The light that comes from the hidden place does not come from burning." We have the image, we have the building, we have the geology, we have the materials, we have the texts. We are standing in front of an answer that the ancient world decided was important enough to hide in the most protected room, in the most deliberately engineered building of its era, and then carve in the most precise script available, and then seal behind a false wall, where it would wait for whoever came next with the curiosity and the humility to look at it clearly. The stone does not answer in words, it answers in images. It has been answering in images for a very long time. The question was never whether the answer was there. The question is whether we are ready to hear it.